Today, our goal is actually going to be to try to get this thing as close to running, if not running, as we possibly can. So in our last video, I kind of gave you guys an overview of the fuel injection system. In some previous videos, we did a bunch of upgrades to the car to support all the modifications that we're doing. And today, I'm actually working on some of the wiring, the fluids, and things like that to get this thing, basically those last few steps, to be able to start it for the first time. So without further ado, we're gonna jump right into some wiring and some other things that we've got to get done on this car. So y'all stick around and check it out. Like I said, really getting started on some of the wiring for this thing. So I've got my coils here. I've already started wiring them up, and you can see I made a mistake here and I had to cut some wires. So I've got basically all my wires joined together for my coil packs. We've made a little pigtail harness for the injectors already. And this little harness here is for the engine intake air temp sensor and the coolant temp sensor. And those just share a common ground, and already made a pigtail here. And this little pigtail here is for the idle air control and the throttle position sensor. And this one was already part of that assembly that I purchased off of eBay. So I just cut off the excess wiring, and I'm going to be wiring on my plug here to go to my main harness. And of course, all of those components are getting wired up with the purpose to go to our ECU here. So this is our Ocelot Speeduino ECU. You guys probably saw this in my last video, but this is really going to be the brains of the operation. So we've got to basically make all the harnesses for all the systems on the engine, wire them over to our ECU. We're going to find a good spot for this thing. Not really sure yet where it's going to go in the engine bay. If you're ever going to do something like this where you're ordering coil packs like the LS coils, or maybe you're ordering a throttle body setup off of eBay, try to get the wiring, at least the plugs that connect to the components, with the component that you're buying. I looked at a ton of listings on eBay for different throttle body assemblies and ultimately made my choice based on the one that actually included the harness and the plugs for the components that are on there, because these little plugs are not super easy to identify and find. Some of them you can find pretty easily. Some of them are kind of a pain in the butt to actually find on the internet. And you're gonna wanna order your assemblies, like I said, with the harness if you can. Our plug for our ECU right here, so the Ocelot, comes with this automotive type plug. This is one of the locking automotive type plugs. It has the seal in there. Hopefully you guys can see that. But anyway, this only really takes a 20 gauge wire. And if I was gonna try to wire 20 gauge wire into these weather pack plugs, they would just be way too small. I ultimately just didn't have the right connector kit as far as the weather pack goes. So I'm gonna redo that with the new Deutsch type connectors, and we're gonna get to building all these harnesses for all these components, and that'll get us just one step closer to putting this all together and making this thing run. All right, y'all, I know I'm doing a lot of talking in this first part of the video, but this is all key information, especially for those of you who are watching and ever want to do something like this on your own. Get yourself a piece of printer paper and just draw everything out and start writing things down, because a lot of times electrical and wiring just gets really overwhelming when you start looking at all the different wires. You know, the coils take 6 wires to run. These two components have 7 wires just on their own together. You got all these sensors and everything, and I can't tell you guys how valuable it is just to start writing everything down and make yourself a diagram so that you can keep track of everything. I got our coil wiring, so I've got my cylinders numbered here, which ones are paired together for my wasted spark setup, and I can't tell you how valuable just sitting down and take yourself a pen and paper and just draw it out for yourself, and it makes this a lot easier of a process. All right, y'all, I went ahead and found a location for our fuse block. Hope you can see that, but it's right here located near our starter solenoid, which is where our positive battery cable will hook to, and just a short distance there for the positive terminal on our fuse block, and I'm making this little cable here at an 8-gauge wire that's going to go just like that. Fuse block is in good proximity to all our components. We just run our wires, our 12-volt positive and ground wires right here to this little spot on the fender, and that should work pretty good. We've got our little terminal in kit here and our wire, so I'm just going to slap all this together. There we go. Got our little jumper cable installed over to our fuse block. Once we get our battery in the battery tray here, we will run a negative wire over to the negative post there, but I'm just going to leave that alone for now. We're calling that permanent location for the fuse block. Finally decided on a location for the ECU. Probably pondered on this way too long, but what we ended up with is we're going to stick it right here in this little spot, down kind of behind the air duct here on the driver's side. Again, our fuse block here, and this is going to be a good location to pull power and ground as we need it, and also in close proximity to all the sensors and everything that are going on the engine. Like I said, you got all these wires, we got our coil wires, a couple other sensors here. So I think this location will be good. It'll keep it kind of out of the heat, away from the turbo, away from the exhaust piping, and maybe get some fresh air over there from just driving down the road and everything. So that's what I ended up landing on. So we'll see how it works out, but now we got to build the rest of that harness. Okay guys, I've been hard at work on our wiring harness. Basically taking all of my plugs for my different components and adding enough wire to get over to our ECU. So these are things like ECT, intake air temp, TPS, things like that. So we went ahead, like I said, extended those out. For my coils, I actually added our Deutsch connector here because the coil pack harnesses are a little more complicated than like these sensor harnesses that just have an easy, convenient plug to unhook. Each coil has its own plug running to it, so that's 8, and then they're actually wired behind these brackets and all nice. So went ahead and added this for our signal wires for our coil. This will be for our 12-volt positive, and of course we have our engine grounds for each bank of coils as well. In the engine bay, just finishing up, got our injector wires kind of routed over here. These are the signal wires. This will be another 12-volt positive that'll run to our fuse block here. But anyway, injector signal wires run over, kind of mocked up to our ECU and its location. So just got those taped really to kind of understand how I want this routing to go. Left myself, plenty of slack here in case we need to tie these up or move them around. But just trying to make headway on this. Not really showing you guys a lot on the wiring side because it's really just a lot of me soldering and crimping and connecting wires together, and that's honestly probably pretty boring. So if you want to see that type of stuff, just leave a comment and let me know, because in future videos and future builds, I'll make sure to include a little more detailed content on that. All right, y'all, moving on to the next thing here. We've got most of our leads extended. The wires are as long as they need to be to get to our ECU. So next I'm going to be pinning out my ECU plug here with all the different wires. I've got my little diagram here that tells me all the different connectors I need. And I've just put a little X next to ones that I think I will need. And some of this is outdated. Like I know I won't need, for example, injectors outputs 4 and 3. But anyway, this is just me kind of getting an idea of how many wires I would need. But nonetheless, we're going to move on, pin this out. That'll build our engine harness. And then we'll be on to wiring up all of our 12-volt power, our keyed ignition power, our relays. And then we'll be having this thing ready to go. Here we go. Got our engine harness all kind of mocked up here. I just threw on some zip ties to kind of hold everything in place. We're going to go back and clean that up. Again, our ECU's right here in this little fender well area. Got my plug pinned out there. Not sure if you can see it in there, but everything sensor-wise is hooked up on the engine. We have a few wires here that I just added extension leads to. Things like our keyed 12-volt power, our constant 12-volt power. We've got a couple of grounds we got to hook up, fuel pump relay wire, and some other miscellaneous things that we may or may not need on this, but I went ahead and added those anyway. So now I'm going to get to hooking up some of our relays. Like I said, we got one for the fuel pump. We'll need one for the ECU so that we can get that turning on with the key. And then from there on, it'll be just wrapping up the rest of this wiring, get our battery tray back in. But we're well on our way to having this thing wired up so that we can fire it up for the first time. Went ahead and pulled off our turbo. As you can see, got our oil drain unhooked as well. And the reason for this is that I am making a little downpipe section out of this old piece of scrap exhaust. I'm probably gonna lop this off right about here, take this piece and then install it with a extra V-band I have to here and get it aimed kind of down in that general direction. And the reason for that is, one, I don't want to fire this thing up for the first time ever on the turbo. There's a lot of reasons for that. One, we don't know how it's going to act. We don't know what it's going to do. We don't want to destroy our costly turbo. We've probably got some welding slag, some metal shavings, things like that that are all in that hot piping that we worked on. And so we just want to give this thing an opportunity to kind of blow all that out of the exhaust. And as well, I want to get a good baseline NA tune on this thing, at least an idle tune, make sure it's going to run right and all of that, just so, again, we don't destroy our turbo and make sure this thing is going to run good the first time. Well, I'll probably end up wrapping this pipe here just to get some of the heat off of our coils, but I'm not going to do that yet because I want to throw an O2 sensor bung on here for our wideband, and I don't have one, so I'm going to have to order that on Amazon. But nonetheless, we got our little dummy downpipe on there so we can run this thing NA. We know we're on the home stretch when we get to the point where we're filling up the transmission, which is what I just got finished doing there, and I'm about to install our shifter, which this is the factory one out of the S10 where this transmission came from. Hopefully it works out, but our threads are just a little dirty here, so I made this little bolt with a couple of grooves cut in it just to kind of chase these threads. And there's, like I said, a little gunk in these holes that's just not quite letting our bolts thread in as smooth as we'd like. All right, y'all, I'm trying not to show too much of the boring stuff, but we are getting things wrapped up here in the engine bay. Got our plug wires on. We are wrapping our harness in some wire loom here. I got one more section of the coil harness to go. I'm going to pull these adapters off. I have another set that's actually made a little stronger. Thank you for all the comments in my last video about the material selection. The PETG or PETG was just what we had available at the time. I saw a lot of your comments about trying the cast aluminum route, and that's something I'm certainly interested in learning about and doing. It's just we are on a time crunch with this build, so I'm gonna try a different 3D printed material first, and then we'll see what happens there. But just to get this thing started up and running, I've got another set that was made out of PETG, but they have a little bit more infill, a little bit more wall thickness and strength to them. So hopefully those will work just to get this thing fired up in A and see if it's gonna run right. We got our fuse block in, working on getting everything wired up for the ECU. Pretty much there. Fuel pump relay is mounted. Our ECU relay still needs a keyed 12-volt ignition source from inside the cabin there. So that'll be wrapped up. We have gotten our alternator charge wire kind of routed here. I know it's not pretty. Positive battery cable, got a new one. Of course, had to go with the old black cable, red heat shrink route, but that's no big deal. Our ground cable is hooked to our engine block, so got a ground right here. It's kind of ready to go. Want to also mention all the people that commented on my last video and said, don't put your map sensor port on your intake elbow. Thank you. I misspoke in that video. I really appreciate all the comments reminding me that my map sensor port has to go on the intake manifold. And I want you guys to know, I'll show you right here. We've got a port right there. You see that barb fitting? That's on our intake manifold, of course, below our throttle bodies. And that is where the map sensor port is gonna go, which is, again, if you didn't see in the last video, that little port right there on the ECU is where our map sensor is. If you guys are ever gonna do this and use a bolt to kind of chase your threads, just make sure when you cut your grooves and your threads that you at least run a nut on there of the same type of thread so that you don't have a burr or something and end up just destroying the threads and the one that you're trying to clean up. So you always want to just cut your groove and try to run a nut on there. But see if you guys can see all that crap right there. I'm not sure what that is. It doesn't look like metal, but definitely some junk in these threads. Shifter's in. We've got gears. We've got a neutral. And actually, I'm stepping back, and y'all please disregard the floor situation right now. We have a whole new floor we're going to be putting in this thing, so just bear with me. But I think that factory shifter is actually going to be in a pretty good spot. Of course, I don't have my seat in, but this looks pretty good. So we're rocking and rolling from the transmission department. We got our ignition coil and ECU relay wired up. I just went ahead and put it on a lead here that we can quickly hook up and disconnect from the battery, so we don't have to jump in the car in case this thing fires up and tries to go crazy. We can kill it just real quick. Everything's pretty much buttoned up. Again, we got that sort of what I'm calling the NA downpipe in. I've got to throw my O2 sensor in. We're going to hook up a wideband so we can monitor our air-fuel ratio. We got the engine filled up with oil, went ahead and did that through our stock fill tube here. And really just kind of buttoning up some of the last final things before we hook up the computer. We'll hook up our laptop to the ECU. We'll download that bass tune. I'm going to show you guys a couple of the parameters. I had a lot of comments in the last video about, you know, certain parameters. And one big thing that was a comment that I saw a lot was about the trigger wheel for the crank sensor needing to be hooked up to where that first tooth was at top dead center on cylinder 1. That is not required. There's a parameter in the control where you can set that advance. Basically, you say, hey, the first tooth is X number of degrees advanced from top dead center. And I don't know this for sure, but there may be some advantage for not setting that on top dead center. Don't take my word for it, but nonetheless, we have a parameter to easily correct the offset of our crank trigger. We're going to be using our Bosch wideband sensor. Come on, focus. So this came with my AEM wideband gauge, and we'll just thread it right into our little downpipe here. And of course, for the one that when we run our turbo, this will be located after the turbo in the actual downpipe. But since we're going to run this setup NA, we'll go ahead and just get this thing installed right here. Sorry for the real crudeness. I'm trying to hold a camera and install this at the same time. Get her snugged up there, not too tight, not too loose. We'll hook that up here in just a minute. Went ahead and rigged up our wideband power on a switch here. So we'll hook this into our fuse block. We got a little rocker switch there. That way we can turn this on and turn it off as needed, depending on what happens with firing this thing up. And we'll be able to kind of set it right here and just watch our air-fuel ratio as we fire this thing up. And again, we can flip that on and off with our switch. So that'll be nice. I'm going to wire up our ECU and injector relay on this, and I'll probably go ahead and put this on a switch as well, just so that we have an easy way to disconnect and shut the thing off if things go crazy. We got all of our radiator hoses on, clamped down, so we're gonna fire up for the first time on just some regular old distilled water. That way, just in case we have a problem, we have to dig into the cooling system, we're not wasting that $12 a gallon antifreeze. This stuff's, you know, only about $1 a gallon. So we'll get her going on this first, and then once we're confident in everything, we'll drain her down a little bit, add some antifreeze, because it does get below freezing here, so we want to make sure she's protected. Well, there's 3 gallons, and that didn't fill her up, so I don't really know how much these old Flatheads hold. Again, no drips on the ground, so she's drinking it all. Let's see. Yeah, she's still dry in the upper tank, so I think I've got 1 more gallon. We'll give her a shot. Well, she drank that 4th gallon too. And we're just to the bottom of the upper tank of the radiator, it looks like, so that'll be enough. I may have to go grab some more, but I think we'll get her fired up on that just fine. Can't forget our oil fill cap here, a breather cap. Gotta keep her original, you know. And it looks like I have the rotation off just a little bit. I didn't even pay attention to that when I put that piece in, but hopefully that's good enough. I'm sure there's still some folks out there watching this, at least hopefully you've made it this far, but y'all can't believe I'm hooking up a USB cable to my Flathead V8. It's pretty cool to me though, that I'm actually able to kind of pull all this stuff together. We'll see if we can get her hooked up here. This is our method for reading all of our sensors and everything, as well as loading our tune in. Get that slid right back up in there. All right, y'all, I'm gonna do my best to kind of show you this as well as I can on the laptop here. This program that we're using is called Tuner Studio, and it is the program that's used to connect and tune our Speeduino ECU. So we already have a project saved here, 1950 Ford Turbo Flathead. Of course, right now we're not turbo, but we are working on a tune that is just our base tune. And here, just on the opening screen, for anybody who's never seen this before, you get some nice gauges laid out here, so I can pick, you know, which gauges I want to see. Right now I have engine speed, throttle position sensor, our injector pulse width. We've got our duty cycle on our injectors. We've got our coolant temp, our air intake temp, and our engine manifold air pressure. You can pretty much customize this layout with any and all sensors that you want. And then down here at the bottom, we have a lot of different, basically like fault code. Well, I wouldn't really call them fault codes, but just states. So like you can see down there right now, we're not connected, but we can have things like tell us, hey, something's wrong or whatever. But anyway, we're not going to worry about that right now. I'll show you guys a little bit in the settings. So we have our engine constants menu here. And what this is basically all the information that is used to tell the ECU what engine we have. So we have our required fuel calculation here where we put in the engine displacement. So in our case, we have a 239 cubic inch V8. Of course, we have 8 cylinders, and our units, we have CID for cubic inches. You could put things in cc's, again, pounds per hour versus cc's per minute for flow rates. But we have our injector flow rate here. That's part of the information that is for the injectors that we have installed. And we have our stoichiometric air fuel ratio. And basically this menu just tells, like I said, tells the ECU everything it needs to know. We're going to control off of our map sensor. You have a couple of different options here. You can control off your TPS and a couple of other things, but map is basically like a speed density tune for those of you who are familiar with that. We have squirts per engine cycle, so this is how many times the injectors will try to fire per engine cycle. I set that to the highest because I want those injectors kind of making pulses, so we want like 8 quick pulses versus 1 long drawn out squirt. And I don't know, that's just something I guessed on. Maybe it'll work, maybe it won't. We're going to fire both injectors simultaneously. We have a 4-stroke engine. We have throttle body injection. So again, you can change here and say, you know, do I have port injection or throttle body? And then how many injectors and that kind of thing. We have some other things up here. Let me see. I want to show you guys the parameter for our trigger setup. So we are using a missing tooth trigger wheel with 36 teeth. That trigger wheel is telling us our crank speed. We have 1 missing tooth, and we have our trigger angle in degrees. And this is the number of degrees after top dead center when tooth 1 passes the primary sensor. So basically, you put in this number, and this tells you that offset between the first trigger and the top dead center and how much distance that is, so that the ECU knows how to calculate and control the spark timing based on the location of that missing tooth. Okay, so we got our laptop over here at the car now. Pardon my angle real quick while I hook up the USB. So we got that hooked up. Okay guys, so I made a mistake. One thing I found, so we finally got our coolant and air temperature sensors going the right way. The one thing that I've got messed up here is right now you can see my throttle showing 94.5%, but I am closed, and when I open the throttle, if I can reach over here, our throttle position is wired up backwards. Okay guys, it wasn't as bad as I thought. All I had to do was go up here to my tools and calibrate my TPS. And as you can see here, our closed throttle ADC count is 219. Our full throttle is 46. The software will throw a warning if the full throttle one is higher than the closed. But if you say accept, which I'm just going to cancel because I've already done this, and if I hit the throttle here, we get normal, we go 100% at full open, and we go 0% at closed, and of course, you know, so it's working fine. Didn't have to rewire it, that's lucky. So it seems like everything is working fine. Again, we got our temperature sensors reading at least somewhere close to what the actual temperature is in here. Our map sensor is reading right at 98 kPa, so that's atmospheric. Got about 5 gallons of fresh non-ethanol fuel here. And for those who were asking in the last video, if you're watching this one, or just for information, I did use a Tanks Inc. poly tank for this thing, and we used their drop-in EFI pump setup, so it's all in the tank. The pump and everything, and of course you have to wire the power to it, but that's how I'm getting the fuel pressure I need for our EFI system, is via in-tank pump module and then our AEM regulator that's mounted to the firewall. So let's get about 5 gallons of fuel in this thing, and we're on the home stretch for real now. Hopefully we don't have any leaks or any problems. This is the first fuel I've put in this tank, so hopefully everything goes well. All right, that's it. 5 gallons down the hatch. Got our cap on, let's see. So no leaks on the filler neck there. No leaks under the car, it seems. Nope. Everything's looking good. Okay, I think I'm going to go ahead and kick on my fuel pump relay. I'll see if I can do that via the ECU, so we'll have to go ahead and hook up our positive cable here, and then I've left all of the fuses out of our fuse block until we had everything ready to go. So throw that fuel pump fuse in. Got a 15 amp blade fuse here. And let's see, fuel pump power. Let me see here. Which one is it? All right, y'all. It's this first one right here. So pop a fuse in that one, and we'll have to put a fuse in for our ECU power as well. Fuses in all of our slots there, at least the ones that we're using. So next up, gonna prime the fuel pump. Let's see if we can force it to run via the ECU. Well, I guess first I need to hook up our positive battery cable here, so we'll do that real quick. Okay guys, got our battery cable hooked up, and also went ahead and hooked up my little remote starter button here, and I'm actually going to go ahead and hook this up to the positive here, and hopefully we have everything out of the way. And this is going to be the first time with all this stuff hooked up that we just try to crank over our engine for the first time. So let's see what happens. Okay, absolutely nothing happened. Okay, well, that's a problem. Let's see. Okay guys, well, I haven't quite figured out how to get the, or well, not how to, but what's going on with that. But I did go ahead and hook up our little ECU power wire here, and what y'all can see, hopefully right there, we got about 40 pounds of fuel pressure. So if I do this again, it's going to prime. And she's running about 60 psi, so we'll need to dial that back just a hair, but no problem right this minute. So we do have fuel pressure there, so I am going to check all of our lines and fittings. This one here, of course, the 3 that we have on our regulator. Not seeing any leaks, not smelling any fuel, at least not at this point, so hopefully everything's good. Alright guys, had to do a little bit of troubleshooting. Our wideband wasn't working. The reason for that is I put the fuse in the wrong slot. So our switch is working there. Wideband will turn on now, heat up, everything looks good. For whatever reason, wherever it went, oh no, guys, my start button here isn't, I don't know if it's not sending enough voltage or what, but for whatever reason, it will not crank the engine over when you apply voltage to the start solenoid there. So not really sure what's going on with that, but if I reach right in here through the vent window and hit the start button, she cranks over just fine, good and fast. So everything looks good there. Let's check if we get an RPM signal whenever we crank the engine over. The answer is no, we're not getting an RPM signal. So I got to troubleshoot that, but anyway, we're working our way to the first time of trying to get this thing to fire off. So actually, it's pretty obvious why I don't have an RPM signal, at least I think it might be. Let me hook this up. So that's our ECU and fuel, basically our ECU power and our coil and everything power. So let's see if we get an RPM signal now that we've got that hooked up correctly. No, we still do not. So I'm going to configure some things here, try to figure out what's going on, why we don't have a RPM engine speed signal, and I'll check back in here in just a second. Well, for those who are curious, you're going to get to see what's inside our little magic box here. So this is our Ocelot ECU. Again, I mentioned before our map sensor is located on the board, but that's not why we're here. We're trying to troubleshoot our no crank signal. And if you see right there, that little red jumper where it says PRI and SEC, so that's the primary trigger and the secondary trigger. And then you have either TSC, which it means through signal conditioner, which is this little thing right here. So this conditions our VR signal for the ECU to read. But I believe the reason that we don't have a crank signal is because I made a mistake and I put the red jumper here on the secondary instead of the primary, so I'm going to move that to there. That should send our primary crank signal through the signal conditioner and then let the ECU process it. So let's make that change and we'll slap this back together and get it back in the car. Okay guys, got everything hooked back up. ECU is powered. Let's hit the button here and see if we get a RPM signal. And we don't. Okay, all right. Well, I definitely had that jumper wire on the wrong wrong post on the ECU, but I'm still not getting a crank signal reading, so I'm gonna have to dive in, troubleshoot some more. Guys, I'm probably just gonna jump back on whenever I figure out what the problem is and show you guys when we get our signal back. So bear with me here, but it's going to be just a minute for me to figure this out. All right, y'all, it's actually a new day because I troubleshot this crank sensor thing for like 3 hours yesterday. Could not figure out what the heck was going on. Ended up pulling out my little handy dandy handheld oscilloscope. We pulled out our electric meter here. I'm checking connections, I'm checking wiring, I'm checking continuity, I'm checking for signals. And ultimately, I can't even really tell you guys what I did right or wrong in this case, but I think we got our problem fixed. So I'm going to show you guys what I'm seeing real quick, and then hopefully we can move on and try to get this thing to fire up. But my face probably doesn't say it. I'm super excited that it's actually working, but holy crap, it took a whole afternoon and then a night of research, and then now it's the next day after work, and I'm finally thinking I'm getting somewhere with this. So we'll show you what we got. Well, I'm not afraid to admit that I screwed this up, and as you guys saw, we have a little bit of run out where when I basically modified the inner diameter of this crank wheel to fit our crankshaft pulley, it's a little off center, and so we get that little bit of run out where our crank sensor is almost has this effect on the trigger wheel. So we cut this one off. We've got a fresh one that was just laser cut out of some 10 gauge hot rolled, and we're going to replace this one with this one, which actually has that inner diameter cut out sort of perfectly to match this. Now I am gonna have to clean up these welds quite a bit just to make sure that this is good and round for our new wheel to go on, but this is also a 36-1. It's a little bit different design, as you can see, because this one's purchased, this one was made, but we're gonna zip the new one on here and see if we can't get this problem fixed. All right, guys, we got that new crank trigger wheel installed. You see it there behind our pulley. Went ahead and got our belts installed, and we're gonna go ahead and check our signal with our little portable, well, not really portable, but with our oscilloscope here. So let me get this hooked up and we'll show you guys what we're doing. All right, guys, got my oscilloscope turned on here, and we got our start button here, so I can just hit this and start the car, or turn the engine over at least. So let's see what kind of wave we get. Oh no, guys. I don't know if you guys saw that, but looks like we've still got run out on our pulley. So maybe the crankshaft or something isn't straight, y'all, but I am just out of options here. This really kind of sucks. So basically what I'm seeing from that oscilloscope, if you guys go back and want to watch again, but the amplitude of our wave is also a wave. So it's like the sensor is near the wheel and then far from it, and then near it and then far from it again. And so we're basically getting a change in amplitude, and I just don't think the control can handle that. So what I'm probably gonna have to end up doing is just looking for a Hall effect crank sensor, and that means a new mounting bracket. And guys, I don't really have enough room up in here to build a new bracket, so this means probably taking things apart and trying again. Well, just for craps and giggles, I went ahead and hooked our ECU and logging program up. So let's see if we even get a crank signal off of this. Nope. I don't know if you guys see right here, this no sync. It's just back and forth, no sync, full sync, no sync, full sync really fast. So y'all, this sucks. If I didn't mention that already, this is really a pain in the butt because I'm trying to get this car going for a big show that's coming up in the middle of September, and I waited 2 weeks. So it's been 2 weeks since the last clips of me like trying to crank this thing and start it, because I had to get the trigger wheel made and I had to, you know, just life in general. So I had to get that in and installed and everything. And I was really hoping that, you know, I had that crank sensor wheel, you know, off center, and that the run out was what was causing my problem. But y'all, that new crank sensor or crank trigger wheel was like laser cut in the middle. So I know the diameter was right. I know it was true to center, and I've got the same problem with the sensor is close and away. So just for whatever reason, I don't know if the snout of the crank is bent or what, guys, but this is my last ditch effort at trying to get this thing going without major upgrades or changes. I say upgrades like there's any more I could do to upgrade it, but basically I have what's supposed to be a Hall effect crank sensor to replace our VR sensor, and I'm hoping that this mounting bracket is pretty much the same as what we've got on the car now. See, we've got our VR sensor here. We're gonna remove our 2 bolts, and hopefully this new one mounts right up, and I'm hoping that this distance from the sort of the sensor mounting bracket to the reluctor wheel is close, so we don't have to remake any of that. Okay, just comparing our 2 sensors here. This is our VR sensor we just removed. This is our new Hall effect sensor, and just eyeballing this, it really looks like they're gonna mount up the same way, and also that the sensor is really close to the same position. Okay, just confirming the new sensor does fit. Of course, I'll have to adjust that distance once I get the nuts on to mount it up, but at least it looks like it's gonna mount in the same location, which is super lucky. And it looks like our trigger wheel is gonna be in the right place. So this may actually work out. All right, y'all, I've got my new Hall effect sensor here on the bench. We got it kind of wired up here. Looks like a mess, but let me tell you guys what's going on real quick. So I have a DC power supply here that I've got set to 5 volts, 4.95, same thing. I've got my multimeter that I'm going to set to voltage here. So as you can see, we got 5 volts there. And what I have here is my oscilloscope, and I should also be seeing 5 volts on it once it boots up. And basically what I can do here is take a metal object, and what I'm going to be looking for is my signal here to change, as well as I should see a step in my voltage reading on my oscilloscope when I pass something metal in front of our sensor. So just grab like a random bolt here off my workbench, and if I hold the bolt up to the sensor, you should see that value change. See, it goes to 0, then it goes to 5, then back to 0, 5, and all I'm doing is moving this bolt near and away of my sensor. So what this confirms, well, I'll show you guys there. You can see the step on our oscilloscope as well. Let me show you all again real quick. Step off, step off, step off, step off. Some of that noise is just me fumbling around with the bolt near the sensor. But anyway, confirmed that our Hall effect sensor is working correctly. Also confirmed the pinout. I went ahead and cut off the connector here because we don't really need that where we're going. And now I can confirm each of the wires and their function and prove that this thing's going to work so that we can get it installed on the car and hopefully mitigate our issue with our runouts and our bad crank signal. There are a couple of things we have to do with our ECU in order to utilize our Hall effect sensor instead of the VR sensor, and one of those is actually removing this VR signal conditioner here. So we no longer need this because we're not running our variable reluctance sensor. And the other thing we have to do is change out our jumper here. So we will move this from the through signal conditioner jumper to the direct, because we again are removing the signal conditioner. Okay, we got our signal conditioner moved, we got our jumper moved over here to the direct channel, and then we also had to add the pull-up jumper since we are using a Hall effect sensor here. So we got that pull-up on jumper 4. And before you guys call me out on this, yes, this is labeled primary, so you would think our tack signal would be on this one, but there was actually a mistake on these boards when they were produced, and the primary and secondary are flipped on this. So I've got this in the correct position, and I have jumper 4 jumpered for the pull-up resistor here. I'm having to do some rewiring on our ECU. So now instead of having just 2 wires going to our ECU for the VR sensor, we need our signal wire, which is staying the same. That's this red here. We're going to tie a 5-volt positive into this white, and then we ran a black wire here that we're going to tie in for our ground. Again, this Hall effect needs 3, and they're different wires than, of course, our VR sensor that only needed 2. Okay, our new sensor's installed, and we've got everything hooked up, wired back up, connected to our ECU. And I'm about to hit this button for the first time. And if we get a RPM signal here, we've succeeded. If we don't, then I have failed, and I have absolutely no idea what I'm going to do. Here we go. That looks like a fail. Hold on a second. Not quite yet. I totally forgot. We actually have to fix this. There we go. Okay. Let's cycle our ECU like it says. So unplug there. Unplug there. Great. Relay back up. Fuel pumps on. So yeah, what I just did there in that menu is change our trigger setting from falling to rising, because I believe with a Hall effect, Hall effect we're supposed to use rising. So let's see. All right, try number 2. Still nothing. Okay guys, y'all will not believe this, or maybe you will, because that's the whole point. But I think I finally got this thing figured out. I have absolutely no idea truly what I did. I scoped things all the way from the crank sensor to the ECU. I moved jumpers around. I added the signal conditioner. I removed it. I did this. I did that. But let me show you guys what we got going on here, because I'm super excited. All right, so we're looking at our program. You guys have seen this a million times already, this video, but I'm going to hit the magic button here and check this out. So as y'all can see, we're getting a constant 200 RPM here, which is probably about right for cranking. We're getting our cranking light showing up here. We're getting full sync, and I honestly, I don't do a great job at expressing, you know, like happiness and excitement and everything just visually, but let me tell you guys, the feeling I'm feeling right now is one that I can't describe, because this entire project has literally been hinging on really this moment right here. And you know, that, like, I've been so discouraged. I've been trying everything I know to try. I mean, I'm researching on the internet. I'm far beyond my own normal capabilities and breadth of knowledge here. But y'all, we've got the cranking signal. We've got a good RPM signal. We're getting full sync on our crank. And I hate to say this, but the only next thing I know to do is hook up the injectors and the coils and see if this thing's gonna light off. So let's give it a shot. All right, y'all, I'm gonna start by hooking up our fuel injectors. Of course, our fuel pump's been working. We've got, you know, fuel pressure coming on here. Still got to adjust that, but we just haven't been to that point yet. And we're gonna quickly hook up our 12-volt power for our coils. We've had this unplugged just while we're doing all of our troubleshooting and everything. So that plugged in should give our coils 12 volts. All right, real quick, y'all, I did actually unplug our injectors real quick, and we got our timing light plugged in, and we're gonna actually make sure that we're getting spark and that our spark is happening somewhere close to the point that we want it to on our crank pulley down there. And first, I'm just gonna hit this starter real quick and make sure that we're actually getting light out of our timing light here. So let's check that out. Yep. I don't know if you guys saw that, but we are getting a RPM signal and a light on our timing light, so our coils are officially firing. Again, I hate to keep jumping on here and talking to you guys face to face, but I cannot seriously contain my excitement right now. I think we're about to hear this thing fire up for the first time on the EFI, and I am just overwhelmed with joy here that we've actually succeeded in doing this. So I don't want to get my hopes up too early, because obviously there's a lot more that could go wrong, but let's take these next couple steps and see if we can get this thing to start up. I know you guys are probably itching to hear it run as much, or maybe even more than me, if you're, you know, really tuned in here. But let's check it out. All right, y'all, we confirmed our timing is at least somewhere in the realm of close. So I'm plugging in our injectors again. And I'm gonna give it just a little douse of some True Fuel here, just a little bit, a couple drops. Try not to go too crazy with this. Just enough to see if she'll pop off. Let's see what happens. I think it tried. I heard like a, you know, I don't know, like a hiccup in there, like it was gonna try to pop off. Is our time, maybe our timing is just way off. I thought I confirmed it, but I'm getting symptoms of timing being maybe way too advanced. I think I got her figured out, and I will admit it's partially because I'm an idiot. Basically, I was putting the trigger angle in the software as the number of degrees after top dead center that the first tooth passed the timing mark on the case, which is just absolutely not correct. It's how many degrees after top dead center does the first tooth pass the crank sensor, but for whatever reason that just didn't click with me, and I'm afraid, or not afraid to admit that, you know, I goofed on that, and so I screwed that up. So I finally figured out, I was like, what am I missing here? And that's exactly what I was missing. I just had to go back and read it like 3 more times. And so we finally figured out how many degrees after top dead center by the timing mark and the mark on our pulley that our tooth number 1 passes our crank sensor, not our timing mark. So again, I'm an idiot, but I think that is what has been going on with this thing and why our timing seemed off. So let's just send it all the way. Let's drop a little more gas down the yap. We'll throw our injector plugs back on. Let's just see if this thing's gonna fire up. At this point, that's really all I know to do. So I don't know. Let's see what we can mess up here. We should be able to give it just a little bit of fuel and try to fire this thing up. Finally, I hope. Because I'll tell y'all, it's getting late and I'm just really getting tired of messing with this crap. All right. Injectors plugged in, coils plugged in. Everything seems like it's good. ECU's powered. Let's see what we get. Oh! Okay, we had something going there. Guys, it just started. Holy crap. It's running. Guys, it's running. It's running, guys. It's running. Holy crap. Guys, it is running. Holy crap. Okay, I just cut it off because, I mean, yes, we have antifreeze, but I'm in a closed-in shop, and honestly, I'm having a hard time breathing already. The fumes are in here like crazy. But you guys, it just fired up. Yes! Oh my gosh, I literally have goosebumps right now because I can't even tell you guys how freaking annoying this whole thing has been to try to get this thing to run, but it just freaking fired up and ran. Yes, it's not idling smooth. Yes, the timing is probably off, but it runs. It sounds like it runs on all 8. It actually sounds kind of decent. Again, I'm kind of dying from fumes in here. We're in a closed up shop. It's nighttime. I don't want to run it too long and, you know, kill myself effectively. Well, I don't want to run it too long and, you know, breathe in a bunch of fumes. But guys, I cannot freaking believe this. Our EFI system is alive. It runs, and I'm just overjoyed at this point. And I'm going to do you guys super dirty, and I'm actually going to end this video right here because it's already probably an hour long. And if you made it this far, thank you so much for coming along this journey with me. This has been a learning experience. And honestly, I have wanted to give up, and I've told my friends, like, I'm not going to get the car done. It's never going to run. But I don't know why I lost hope because, you know, ultimately I kind of knew I was going to figure it out. I just didn't know when. And, but anyway, I'm going to end this video off. Like, subscribe. Thank you guys for watching. In the next video, we're going to get this thing dialed in. We're going to start doing some tuning. I'm going to get our new wheels and tires installed. We're going to get this thing off the jack stands and hopefully get it to where we can roll it outside and, you know, start it up, do a little tuning, like I said. But anyway, thanks for watching. Y'all have a great one, and come back for the next video because you guys are one thing that really helps keep me motivated on this thing and keep me moving. So thank you again for all who have subscribed. We'll catch y'all in the next video.